Hello and welcome. My name is Mildred. In Python, we have data types that we can use to store more than one value in a variable. The first collection type we are going to look at is list. We create a list in Python just the same way we create a variable, but this time, let's say this is my list. We are going to assign several values in a pair of square brackets. Within that pair of square brackets, we can assign any data type. Strings are quoted, numbers are not quoted. You know the rules of data types. I want to have this list of different names in this variable. And so I declare my square bracket, and then I want to write my names. So let's say, okay, so let's have this list of 7 names. We'll say print my list, and we run. We're going to have the list printed out. Lists are declared in a pair of square brackets, and as a comma separated list, all of the items that the list will hold. Now, some of the things you need to bear in mind when you use lists is that lists are ordered. The order of a list doesn't change except you use methods that you use to insert something in a particular index, or you want to delete something from a particular index, but the order naturally doesn't change. Whenever you add a new item, it adds to the end of the list, except again, you use a method to insert at a particular index. They are ordered, they are changeable, and they allow duplicate items. So we can have Jesus appear twice here if we want. So because they are indexed, it doesn't matter. It will only say the Jesus at index position, the first index position 2, the Jesus at index position 7. Indexing starts at 0, so we have 0, 1, 2, 3, 4, 5, 6, 7. We can also create lists using the list constructor. Let's say we have my list 2. Normally in Python, you want to stick to particular convention. You see I'm using camel case, but I recommend you use snake case like this, my list, right? So you want to read about conventions, and when you get into the software development industry, your team will decide what convention you stick to, what rules you guys are working with. But you want to bear that in mind that these things exist. You want to learn with good habits where you want to keep your code neat and understandable. So my list 2, and this second list, I want to have some set of names that are different. So let's have, that list has 6 items, which means that index position 0 to 5. So 0, 1, 2, 3, 4, 5. Indexing starts at 0. If I have a second list like this, we can actually combine 2 lists, but we're going to look at that later. Another way I can create my second list is by using the list constructor instead of the square brackets, list, and then in the pair of parentheses, I am going to list all of the items in the list. Now take note of something. The list constructor and a pair of parentheses, you need to have a second pair of parentheses for the items. So in a pair of parentheses, you are going to list the items in a pair of parentheses. Don't know if that makes sense. So it's like this. You write the list constructor, and then you put your items in a pair of parentheses. So there are 2 parentheses for the list constructor for you to create a list using the constructor like this. Either way, we are going to have the same list printed to the page. So I can say print my list 2. And then I'll print this to the page. Let me clear so you can see. And then we have both lists printed. Since we have these items indexed, we can get items by referring to their index position. So we can say print list 2. I don't want to print all of it. I want to print out a particular item at a particular index. So I'm going to write the name of the variable that holds my list, a square bracket, and then I want to say, for instance, I want to print out James. So 0, 1, 2, 3. I want the item at index position 3, like this. And so when I save this and I run, I'm going to have that printed James. Now this is not the best way to get items at positions, because if you are extracting things from the database, you might not know in advance how many items there are, what are the last index or something. But you can always look for the length of a particular list. And let's say we want to see what is the length of this, so we'll print length. So we want to print the length, len, and the pair of parentheses, the name of the list, like this. When I run this, I'm going to have the length of my list 2 is 6, which means it has 6 items. When you want to see the index, it's always 1 less than the length because indexing starts at 0. So if the length is 6, the last index is 5. If the length is 10, the last index is 9. So bear that in mind. We can also use negative indexing when we want to get items from behind, from the last item instead of from the first. So let's say, for instance, I want to print my list, and I want to print the item at the last item. I'll use -1. Every time you want to see what the last item of a list is, you use -1. -2, second to the last, -3, third to the last, and like that. And so when I save this and I run, you will see the last item of the first list, which is Jesus, printed to the page. We can select from a list. Let's say from this first list, I want to select Jesus, Mary, and Joseph. Jesus starts at index position 2, that's 0, 1, 2. Mary is 3, Joseph is 4. So we want to get index position 2, 3, and 4. There's a short way we can do this by using 2. And then if you recall how we did with string slicing, it's almost similar, where you specify the start index and then you specify the end index exclusive. So if this is 2, 3, 4, we want this to be 5 because the last one is not inclusive. So if I put 2 to 4, I'm not going to get Joseph printed. I have to use 2 to 5 so that I can get Joseph printed. When I save this and I run, I will get Jesus, Mary, and Joseph printed. So we can also use negative slicing like that. If we leave out the first, we print from 0 to the stop index. If we leave out the last, we print from the start to the end. And if we want to say we want to look at negative, for instance, I want to print the same Jesus, Mary, and Joseph, but I want to use negative index. I'll say negative, this is -1, -2, -3, -4. So Joseph is -4. So I'm starting from -4 here. Then -5, -6, -7. I want to print Jesus, so I'll stop at -7 because it's exclusive. So when it's supposed to be -7, -4. But let's save this and then let's run. You will see how confusing the negative slicing is. So we'll look at it and it's empty because I did -4, -7 instead of -7. They start -7 from the back to -4. We'll save this. We run and you see John, Jesus, Mary. Now why is it John, Jesus, Mary? Now let us see why this gets confusing. Now if we say this is -1, 2, 3, 4, 5, 6, 7. It is the end that is not inclusive. So which means we are doing -6, -3. So let's count again. -1, -2, -3. So this is going to be where we want it to stop. -4, -5, -6. We want it to start at Jesus. So -6, -5, -4. We don't want to print this. And that is the logic behind. You see how complex it is? So we'll have Jesus, Mary, and Joseph printed. I'll clear and run again so you can see this. Jesus, Mary, and Joseph. Now I'm making this mistake so that you can see how easily confusing negative slicing can get. So this is how we do negative slicing of lists if we want to get particular parts of the list. Let's say we want to change an item at a particular position. Let's say we want to change this last Jesus here to something else. Let's say we want to change this to Peter, for instance. 0, 1, 2, 3, 4, 5, 6, 7. It's at index position 7, or we say -1. So what we want to do here is I'm going to remove this print statement. We want to say my list item at index position 7 should be equal to, and when we do this and we print my list, we will see that I'll print my list here first. So you see the first one. When we print my list, we are going to have this last item replaced with Peter. So I'll save this, I will run, and then we have that as Peter. So this is how we replace things at a particular index. Now this is for illustration purpose. It will be difficult for you to really use this in the software development world because most of the time the data you get are things that you might not know in advance, but it's good you have this knowledge in case of data analysis and things like that. So this is what it is. So we can use -1 instead of using index position 7. We want to say we are replacing the last index with this. We're going to use -1, and let's say this time is not Peter, we want Judas. And when I save this and I run again, we're going to get, I'll clear this so you can see properly, Judas replaced. So -1 refers to the last index, or you can count and see where the index position ends. We can also use slicing to change items. Let's say we want to change from 0, 1, 2. We want to change from 2 to 3, 4, 5 exclusive. From 2 to 5. We want to change something. We want to change this to, I'll use a list, and I want to add David, Solomon, Elijah. There are 3 items I want to replace: Jesus, Mary, Joseph, with David, Solomon, and Elijah. And so I'll run this, and then we'll have Jesus, Mary, Joseph replaced with David, Solomon, Elijah. Now I said 2 to 5, which means that index position 2, 3, and 4, the last is not always inclusive. But let's say I want 2, 3, and 4, and I want to add Elisha here, but I still left it at 2, 3, and 4. What this does is that it shifts everything to the right and takes as much space as the number of items you provide. So even though I specify 3 index to be replaced, I want 4 items inserted. So what will happen is that it's going to shift James to the right. So James currently is at index position 0, 1, 2, 3, 4, 5. Index position 5. It will shift James to 6 so that it can accommodate the new item whose index I did not provide. And so when I run again, we're going to have Elisha in the position of James, and James shifted to the right. And this is how we use list, replace items in a list. We have already seen how to get the length of items in the list by using the length method like this, and then you specify the name of the list in the pair of parentheses. If we want to insert items at a particular position, let's say I want to insert an item at index position on the second list, 0, 1, 2, at index position 2. I'm going to say insert, and I want to insert into index position 2, and what I want to insert there is Peter, and I want to now print my list underscore 2. So what I'm inserting is I'm inserting this method on my list underscore 2 dot insert. Now the method we use is the insert method, and we insert at a particular index position that we specify as the first parameter, and then the value we want to insert there as the second parameter. And so when I print this, I'll clear other print statement here so that you don't get confused. So when I run this and I print, I will get Peter inserted at index position 2 and Joseph shifted to the right to accommodate the new insert. And so that is what we have here. So the length now changes to be 1 higher because I inserted at a particular position. If I want to insert items to the end of the list, what I do is I use an append method. I want to add Paul, so I will say my list 2 dot append Paul. And once I do that, save and print my list 2. I'll clear here and run. You are going to get Paul appended to the end of the second list. But we have 2 lists. We have my list and my list 2. Let's say we want to combine these 2 lists. There is a method we call extend that we can use. So we can say my list dot extend, and in the pair of parentheses we are going to specify the second list to add to the first list. And when I print my list now, this time I'm going to have both lists combined into a new list that will be printed, and so I have all items from both lists in one list. So we use the extend method to combine 2 lists together. We use the append to add an item to the end of the list. If we want to remove an item from the list, we can use the remove method. Let's do that. Let's say my list dot remove. I want to remove Jesus from this list. I want to remove a specified item. I want to remove Jesus. There are 2 Jesus on this list. Now I'll show you what happens. When I save this, I will clear, and then we run. In the first item, there are 2 Jesuses at index position 2 and at the last index. When you try to remove an item that has duplicates, it is going to remove the first occurrence of that item. If, let's say, I want to remove from a specified index, I can use my list dot pop, and then I'll say the index position. Let's say 0, 1, 2. I want to remove Mary this time, 3. When I print my list, Mary is going to be removed from the list. If I want to remove the last item instead, I won't specify an index here, and when I print my list, the last item, the last Jesus, is what will be removed from the list. If I want to delete from a specified index, I can use delete, for instance. So use DL like this, DL, and then I'll specify my list, and I want to delete this from, let's say I want to delete Jane 0 from here. When I print my list, Jane is going to be deleted from the first list. If you do not specify any index to be deleted and you use delete my list like this, you are going to be deleting the entire list. So I'm going to remove this, and then if I print my list will no longer exist because I deleted it. So when I save this, I'll clear and I'll run. I deleted my list, and then there is no my list is not defined because we deleted here. So once you don't specify an index and you use delete, it is going to delete the entire list. If you don't want to delete the list but you want to empty the items in the list, we use the clear method. Let's say my list2.clear, and when I clear, I'm going to have my list2, but it's going to be empty because I cleared all the items in the list. So when I run this, we'll have empty list because I cleared. In the next lesson, we're going to look at more list methods and list comprehension. Thank you, and see you in the next lesson.